if we look at example, okay, this is example 2. This is going to be example 2. If we look at this example 2, we can see that there's a close affinity between it and the first example. And of course, we can relate them to each other. If, for example, you are given that a boy, maybe let me say, 3 boys were given 30 naira to share in the ratio 2:1:3. And they now ask you, who got the largest share? The largest share is this 3. Largest share is this 3. It will be 3 over the total ratio, which is 6, times what they share, which is 5. So when you multiply out, you get 15. So we know how to answer this. So if you look at this example 2, what we need to do or think of doing is, how do we find their combined ratio? The common ratio or the combined ratio for SS1, SS2, and SS3. So in this case, we quickly say, to facilitate the working, we can represent, let SS1 be X, SS2 Y, and SS3 Z. So we can try and find their combined ratio X, ratio Y, ratio Z. But how do we do this? From here, they say if six players were selected from SS1, if 6 players were selected from SS1, 7 will be from SS2. If we have 6 players were selected from SS1, 7 will come from SS2. And with 5 players from SS1, 9 will come from SS3. So we can see now that the central or if we want to standardize the ratio, the common one is SS1, because in the first statement, if 6 players were selected from SS1, 7 will be from SS2. And if 5 from SS1, they still mention SS1 again, meaning that SS1 is the standard, is the middle ratio. So in this case, the first statement here, which says that 6 players from SS1, SS2 will be 7. So it will be SS2 ratio. You know, the other time we say A ratio B, B ratio C. If you want the B to be in the center, and in this case, our X is that B. So we can say SS2, 7, and SS1, 6. Instead of saying SS2 ratio SS1, just say SS2 is represented by Y, Y ratio X equals to, that is 7 ratio 6. And the second one, if 5 students came from SS1, then 9 will come from SS3. That is X ratio Z equals to 5 ratio 9. If we standardize the middle ratio, we know that the value of X will simply be 5 times 6, which is 30. So if the value of B is 30, if the value of X is 30, and we have 7 ratio 6 here, that means X was originally 30 before it was reduced to 6. What was used to divide 30 to become 6? It is 5. 30 divided by 5 will give this 6. That means if you use 5 to multiply 6 by, you get this 30. That means this one too, the same factor must have been used to reduce the original value of Y, which is also 5. So Y will now be 5 times 7, which will be 35. And similarly, to get the original value for Z, since X already takes the value 30, What was used to multiply this 5 to become 30? Because this 5 belongs to x. That means 30 was reduced by something, was divided by something to get 5. It is 6. So since it is 6, they used to multiply 5 to get 30. You use the same 6 to multiply 9. So if you say 9 times 6, you get 54. So Z will be 6 times 9, which is 54. This implies that X ratio Y ratio Z equals to 30 ratio 35 ratio 54. And from here, if you are now asked to find the share of each, so that means SS1, those that will come from SS1, which is represented by X, will now be 30 over the total ratio. The total ratio is 30 plus 35 plus 54 over 119 multiplied by, we have 238 players altogether to choose from. So that is times 238. And if you multiply this out, 30 times 238 equals to divided by 119. That should give us 60. That is 60 players coming from SS1. Then SS2 is Y. And the value of Y will be 35 over the total ratio, 119, times 238. So this gives us 70 players. And lastly, SS3, which is denoted by letter Z. Letter Z. The apportioned value for Z or ratio for Z is 54 out of total ratio of 119 times the total number of players from the school. And that should give us 108 players. So this is how to handle this type of problem.